Hey guys, in this video we're going to go straight to equations of equilibrium. So we know that for a rigid body in 2 dimensions, we have these 3 equations of equilibrium. So only these 3 equations are enough to satisfy the equilibrium state of a rigid body. Okay, summation of fx, summation of fy, and summation of moment equals to 0. So summation of fx and summation of fy represent the sums of all the x and y components of all the forces that you have. And summation of moment represents the sum of all the couple moments and moments of the force components. So to solve a question using the equations of equilibrium, first we need to draw the free body diagram. So you've learned this in previous video. Now we're gonna try to apply this again. And then we will apply the equation of equilibrium. Okay, so force is equals to 0, moment equals to 0. So we have 3 equations, and therefore we can use them to determine any unknowns that are in the problems. Okay, x and y components should be oriented along the lines that will provide the simplest resolution of forces. So typically it's the horizontal and vertical axis, right? But sometimes, as you've seen in the moment chapter, the x and y axis can be rotated by a certain angle. Next, if you have a negative result, okay, when you calculate, that means that you have assumed a wrong direction on the FBD. So we'll see this in the example. Determine the horizontal and vertical components of reaction for the beam caused by the pin at B and the rocker at A. Neglect the weight of the beam in the calculations. Okay, so determine horizontal and vertical components of reaction at B and A. So we have at point A is a rocker. So you can pause, check in your notes how does the forces react on a rocker. And then we have a pin at B. So what forces do we have here? Okay, so you'll find that for the rocker, there's only a vertical reaction force. So we label it as AY because it's at point A. And then for point B, this is a pin, and we will find out that there's BX and BY. There will be 2 forces and no couple moment. Okay, so let's go straight to the solution. First, we draw the free body diagram. I really encourage you to follow this, as in take a piece of paper and a pen and try to work this out as you watch this video. So let's keep the diagram here for your reference. First, we draw the outline of the body. Okay, so we just have the beam, and then we label the points. Here's point A, we have point B, and we have point D. Then we establish our X and Y axis. Alright, so let's put the forces down. Here we have the 200 Newton force. And then here we have the 100 Newton force. These are all given in the question. For now, we are neglecting the weight because that's what the question told us to do. So don't have to include the weight. And the 600 Newton force. So you can just leave it as 600 Newton at this angle. But to make it easy, I'm going to represent the 600 Newton by its X and Y components. So just resolve the force. Okay, we know the angle, so just put both forces here. And the location and direction will follow the given vector. Okay, this is pointing downwards and to the right, just like this. And now we go to the reactions. So at point A, we have AY, because this is a rocker. At point B, we have BX and BY, because this is a pin. Now, note that the support reactions act exactly on the points of support, meaning that for AY, it's acting here at the center because this is where the rocker is attached. And for B, it's the same thing. This is where the pin is attached on the beam. So this is where it acts. Not like the 200 Newton force, which is acting externally on the surface. And then we put in the distances between the points, and don't forget this one, 0.2 meters. This makes a lot of difference when you want to calculate moment. Now we can apply the equations of equilibrium. Don't forget that our main objective here is to solve for the unknown forces. Alright, so we're going to use these three equations, and we're going to base it on our FBD that we have drawn, which we can see that there are three unknowns, AY, BX, BY. So this is what we're going to solve for using the equations of equilibrium. Okay, now how do you start? So to start, use the simplest equation first. The simplest will be based on your FBD. So look at how many forces do we have in the Y direction. We have AY, we have this 100, we have 200, and we have BY. So we have two unknowns in the Fy equals to 0 equation. Okay, so not very simple. You can't solve two unknowns using one equation. Let's go to Fx. Fx, we only have 600 cos 45 and Bx. So one unknown, one equation. So we can solve that first. Summation of forces in x direction equals to 0. We have 600 cos 45. This is positive to the right. And Bx, we assume it's to the left. So we write negative Bx equals 0. So from this, you get the magnitude of Bx. Now you get the answer as positive. That means the assumed direction, okay, we assume the arrow is pointing to the left, the direction is correct. So we can keep it like this. Okay, now that we know Bx, we can solve moment about point B. Why? Because we still don't know By. So we still have two unknowns in the Y direction. So we go to moment about point B, because when you solve the moment about point B, you will automatically ignore the forces acting on point B. Remember, because the force will act through the point. It will not cause any rotation. So if you solve for moment, you'll straight away only have this one unknown, which is AY. So doing that, solving for forces at point B, we have this force, 100 newtons, times the length from point B is 2 meters, okay, perpendicular distance, and then it's acting counterclockwise, is positive, and then plus the next force is 600 sine 45, acting 5 meters away, perpendicular distance, also counterclockwise, so still positive. And then the next force is 600 cos 45. It's only 0.2 meters apart from point B, and it's going clockwise. Okay, so it's negative. And the last force is we have AY, which will create a clockwise rotation also. And the distance is 2 plus 3 plus 2, 7. Okay, so we ignore 200 newtons because it's going to act through this point. Of course, we ignore these two as well. Okay, so you can solve this equation and you'll get AY equals to 319 newtons. And it's again positive here. That means this direction that we have assumed is correct. Okay, now we know AY, we can solve for BY. Summation of force in the Y direction. There. We have AY going upwards, so positive, minus 600 sine 45, minus 100, and here we have minus 200, it's going downwards, and plus BY. Okay, so put AY as 319, you can solve for BY equals to 405. Okay, so that's it for the most part of chapter 5. Okay, I'm going to supply a lot of examples in PDF form, so you can go through them, okay, for you to understand this topic better. It's just a matter of drawing the FBD and applying this three equations.